All right, we're going to keep going with our unit on exponential functions, and this video will cover how we can multiply powers that have the same base. And we'll do an introduction first and then a couple examples. So, reminder that an exponent is just a way of counting how many times we're multiplying something by itself. And so here's our rule for multiplying powers. If we have something like x to the n times x to the m, that's going to equal x to the n plus m. Okay? And here's what you really need to remember. This multiplication sort of kinda turns into an addition problem. Okay? And a couple key things though. The bases have to be the same. So this only works if those two bases are the same. And it only works if we're multiplying. It doesn't work if we're adding or subtracting, okay? We'll get to a division property down the road, but we need to be multiplying here. And let's talk about why it works. I don't like just giving a rule and having you trust me, but let's talk about why it works here. So let's say we had, 3 to the second times 3 to the fourth, okay? So using the rule, we would add the 2 and 4 together, and we will get 3 to the sixth. But let's write it out kind of longhand. 3 to the second is 2 3's being multiplied together, and 3 to the fourth is 4 3's being multiplied together. And then we're multiplying these two terms together. I think you can see everything's just a multiplication here, and we just have 6 3's all being multiplied together. So it does equal 3 to the sixth. So that's why that rule works. Here's what you can't do. 2 to the third times 3 to the eighth is not equal to 6 to the 11th. Okay, some people think that that might be true, that we get to multiply these, and then we get to add the exponents, but this is a not valid thing to do. Okay, so don't think that you can do that. You can do some things like this, and if you're ever stuck wondering if you can make a shortcut, write it out longhand and see if it works. Let's try something like this: 2 to the third times 5 to the third. Okay, so it's not going to be 10 to the sixth, but let's see what it might be. Okay. So this is 2 times 2 times 2, and this is 5 times 5 times 5. And can you see some rearranging, some grouping we can do? We can kind of interweave the 2's and 5's. So we have 2 times 5, 2 times 5, 2 times 5. So it's going to be 10 to the third. Okay, so there's another rule that you can follow. So 2 to the third times 5 to the third. We won't use this rule very much, but if the bases are different and the exponents are the same, in general you can just multiply the bases together and keep the exponent the same. Okay, but this is our main rule for today. Okay, if the bases are the same, and we're multiplying, we can add exponents. So let's do some examples. Okay, 9 squared times 9 to the fifth. Let's check it. Bases are the same, so that's good. So we have 9 to the seventh. If your teacher asks you to actually evaluate that and actually do 9 to the seventh, you should. Go to your calculator and do it, and we get a pretty large number. I'm getting 4782969. But if your teacher doesn't specify, I think this is a fine final answer. Negative 3 to the fifth times 3 to the negative sixth. I'm trying to trick you a little bit here, and let's see if you can figure it out. Take a moment to think about it. Do we have different bases or not? We actually have the same base. So this is going to be negative 1 times 3 to the fifth times 3 to the negative sixth. So for these pieces right here, we can do our addition problem, and it turns into negative 1 times 3 to the negative 1. 5 plus negative 6 is negative 1. And then we can bring this piece down below because it has a negative exponent. So negative 1 over 3. Okay, let me try to color coordinate. This negative 1 corresponds to that negative 1 right there. All those highlighted negatives are the same one. And then this negative 1 came from adding those two guys together, and that's what got us the 3 in the denominator. Okay? And then similarly for this next one, we can look at a -6 to the -1 times -6 to the 3. So that's -6 to the -1 plus 3, which is -6 squared. Okay? Which means -6 times itself, which is 36. And then we can similarly do all of this work with variables as well. It doesn't have to just be with numbers. So we can kind of clump like terms together and do some simplifying. So it looks like we're going to have a 3 up top and a to the 5th up top. And we have b to the -4th, because this b with no exponent has a implied exponent of 1 right there. Okay, so that's b to the -4th. And then we can bring that b down below and make it a +4. Same thing with this next one. We can just add the exponents together. We have common bases with the x's, and the 3 is just going to go along for the ride here. So we have 3x to the 7th, adding those exponents together. All right, in a prior video, for this next one, we actually simplified it down and brought the a down below, but let's try to be a little more efficient with it here. There's an implied exponent of 1 right there. Right there is an implied exponent of 1. So we can add, because we're multiplying those two terms together, we can add the exponents, and we get 4a to the 0, and a to the 0 is just 1, so we get a 4. All right, let's keep on rolling here a little bit, and we're going to do an evaluation couple of problems. And again, my suggestion with these is, if you can, try to simplify as much as you can first, but it looks like for both of these there's not much simplifying to do, so we're just going to plug in. Okay, so for this first one, we're going to have 5 times 2 squared, and then the -3, let's put it in parentheses because we want to raise the entire value of b to the 5th. Okay, so 5 times 4 times -3 to the 5th. I'm going to go to my calculator and make sure I type in my parentheses, and I get a -243 times 5 times 4 times 20. So my final answer is a -4,860. All right, and for this next one, we're going to plug in a half for a, so -6 times 1/2 squared, and then we're going to plug in 2 for b, and then a 2 squared. Okay, it looks like, remember our little addendum added on rule that we did at the beginning of this video, where we have different bases but same exponents? I think that rule is going to apply here. But let's show our work. We have a -6. A half squared is a quarter. So the other thing you can do, and we'll talk about more about this in another video, but if you have a fraction all raised to a power, let me zoom in here so you can see. This 2, and one way to think about it is it gets applied to both the numerator and denominator of the fraction. Okay? You can also just think of it, what's 1/2 squared, right? But you can think about it as 1 squared over 2 squared, and then we have this 2 squared at the end. So -6 times 1/4 times 4. So just like we predicted, these guys cancel. So our final answer is -6. All right, so lots of work with using the multiplying powers rule. When we're multiplying terms with the same base, but with exponents, we can add those exponents together. That's a good place to stop.